Let's take a look at the questions on homework number 24. First, it's to determine if a number is rational or irrational. So there are two requirements you have to fulfill in order to be irrational. An irrational number has to never end, that's called non-terminating, and it has to never repeat. So if you don't have this memorized, the square root of 25, you can always turn your calculator on, and you can press second x squared, type the square root of 25, and if you get a whole number, that makes it a perfect square. Perfect squares are rational. So underneath the question, you'll be prompted to choose whether you're rational or irrational, and when you pick rational, you will choose that because that was a whole number, square root of 25, that it is a square root of a perfect square. The answer was 5. It was not a decimal value, it was just 5. So we can't choose any of these ones that say it's a decimal, because the answer was not a decimal. It's the square root of a perfect square. Next problem, this one has 3 dots at the end, so that means it is non-terminating. That means it never ends. So it can be an irrational number. Let's check the second requirement. You have to have no pattern. So 2, 7, 3, 2, 2, 3, 7, 0, 0. Nope, there is no pattern. So this is irrational because it is a decimal that does not repeat and it does not terminate. Let's take a look at one more. It has the 3 dots, so it has the potential to be irrational. Let's check the pattern. 7, 9, 6, 5, 3, 5, 5, 3, 5, 5, 3, 5, 5, 3, 5. I hear it, 5, 5, 3. I keep hearing it over and over again. So that is a pattern. That makes it rational. It's rational because it is a decimal that repeats. It's a decimal that repeats. The beginning part of the decimal doesn't have to repeat, but any part that does repeat makes it rational. All right, let's take a look at the next topic, simplifying radicals. This is a guided version, so it's going to walk you through each step before you can submit it. So the square root of 252 has to be broken down into 2 separate factors. The goal of writing it as 2 factors is that you look for these perfect squares. Now I only have the first 9 written here. There's more than 9 perfect squares, but this will help us to get started. So the square root of 252 needs to be broken down into 2 separate square roots. So I'm going to use my calculator, and what I'm going to do is I'm going to divide 252 in half. Oh no, sorry, yes, 252 divided in half. All right, about 126. So that means I can probably try any number that's lower than 126. So I'm going to try, just starting at the top there, 256, oh sorry, it's 252. 252 divided by 81. Nope, doesn't work. 252 divided by 64. Doesn't work. 252 divided by 49. Doesn't work. 252 divided by 36. Oh, it does work. So now I've got my product of 36 and 7. And because 7 is prime, I know that I couldn't have found a bigger number here. Couldn't have found a bigger number here because 7 is prime. So the square root of 36 can be found. That's 6. Because 36 is a perfect square. Square root of 7 cannot be found. So this is the simplified answer of the square root of 252. Now let me show you another trick over here on the calculator. The square root of 252 is about 15 point something. So I knew I needed to choose a number below 15, and 6 is. All right. Back to the question. We're going to type here that we chose 36 and 7. Then we're going to find the square root of 36 and leave the square root of 7. And now we can submit it. Let's try that one more time. Square root of 96. I'm going to go back to my perfect squares here. Square root of 96. Well, something times itself has to be 96. And we know that there is no perfect square for 96 because the next one here would be 100, right? So let's see. 9 times 9 is 81. So it's definitely not going to have an 81 here. It's too big. 81. So I'm going to start checking here. Half of 96 is around 40-something, 45-ish. So I'm going to check with 36. 96 divided by 36. Nope. 96 divided by, I know 25 doesn't work, but I'll just show you. 96 divided by 16. And we found it. So 96 is 16 times 6. And 6 is can be only written as 3 times 2, and neither one of those are a perfect square. So I know that I found the simplest form here. Square root of 16 and 6. So let's go back here and write that. 16 and 6. It will allow us to find the square root of 16, but leave the square root of 6. And we're done. All right, now let's try doing that without guided practice, right? Let's try doing that on our own. The square root of 20. So if I look at my list of perfect squares here, the square root of 20, well, it's got to be less than a half, so it's got to be somewhere here. So I know 9 doesn't go into 20, but 4 does. 4 times 5. So I'm going to separate this. And the square root of 4 is 2. Square root of 5 cannot be found, so that is how I simplify. 2 square roots of 5. So I write 2. I choose the square root sign, and then 5. Let's try one more here. Square root of 8. So I'm going to go back, look at my perfect squares. So it looks like 4. So 4 times what makes 8? 4 times 2. Square root of 4 times the square root of 2. So 2 square roots of 2. 2 square roots of 2. Let's try one more. See if we get a bigger number. 72. So square root of 72. I know that 9 times 8 works, but I'm curious if something bigger than 9 works. So I'm going to use my calculator, and I'm going to start with something obviously lower than 72. It's probably even going to be lower than half, so I'm going to start with 36. 72 divided by 36. Oh yeah. So this one was too small. But the square root of 72 can be written as the square root of 36 times 2. So 6 square roots of 2. So let me show you if I had done this over here. If I had done this over here, I would have gotten 3 square roots of 8, but 8 has a perfect square in it, right? 8 can be written as the square root of 4 times the square root of 2, which is okay if you do that, but it's more work if you don't choose the largest perfect square factor. So what I would have gotten here is 3 times the square root of 4 times the square root of 2, and this is 2. So I would have gotten 3 times 2, which is 6 square roots of 2, which is exactly what I got before, but with a lot less work. 6 square roots of 2. Okay, let's go back and try the next topic here, which is sum and product of rational and irrational numbers. So let's take a look here. 5 square roots of 4 and 2 square roots of 9. You could certainly cheat and put in here 5 square roots of 4, and then a sum is plus 2 square roots of 9. You can certainly do this and check to see what you get. We get a whole number. But what we're really hoping for you to do is understand that the square root of 4 is a perfect square. So 5 square roots of 4 plus 2 square roots of 9 is 5 times 2 plus 2 times 3. Or 10 plus 6, which is where that 16 came from. Okay. If your answer is a whole number, it's definitely rational. So we've got 16. Here's our answer. The result is rational. And if it's rational, all of these are cans, right? And does. It can be written as a ratio of 2 integers, and it does terminate. Let's try this one more time. The square root of 7, and we want a product. Square root of 7 times 2 square roots of 2. Well, there's a 1 out here, so it's 1 times 2, and the square root of 7 times the square root of 2 is 2 square roots of 14. 7 cannot be factored, 2 cannot be factored, so I'm done here. I'm done here. If you had tried to cheat and use your calculator this time, the square root of 7, and then times it by 2 square roots of 2, you would not have been able to write it in simplified form. That's decimal form. and you can't write that here. So you do have to know how to simplify a radical. 2 square roots of 14. So I'm going to write that down here. 2 square root 14. That is irrational because it cannot be written as a ratio and it does not terminate or repeat. One more time. 5 square roots of 3. Oops. 5 square roots of 3, and we were looking for a sum. 4 square roots of 3. If the radicands match, you can in fact combine. So 5 square roots of 3 and 4 square roots of 3 are 9 square roots of 3. That doesn't change. It's like a common denominator, right? It's a like term. 5 square roots of 3 and 4 square roots of 3 gives you just 9 square roots of 3. 9 square roots of 3 is irrational because the square root of 3 is irrational. And so we will say it cannot and it does not. Next topic, multiplying and dividing radical expressions. Multiply and divide radical expressions. All right, this actually is not a multiplication problem. This is just a simplification problem, but okay, let's go with it. The square root of 24 can be written as 2 factors, right? 24 is 8 times 3, 12 times 2, 6 times 4. You can choose any factors you want, but preferably you should be choosing a factor that is a perfect square, right? Like we did in the guided lesson. So I mentioned numbers like 12, 2, 8, 3, 4, and 6. Well, 4 is definitely a perfect square. 6 does not have any perfect square factors. It has factors of 3 and 2, so that's good. I know that square root of 4 is 2. And so that has been simplified. Square root of 24 has been simplified. And now what we want to do is take a look at these coefficient numbers out here. Those can be reduced. Radicals can never be reduced, but these free numbers on the outside can. And 2 divided by 2 is 1. So 1 square root of 6 is the same as the square root of 6. So this is square root 6. You cannot divide a radicand by a free number, so you can't divide these. Next, all right, square root of 1, 2, 1, 5, and the square root of 5. Now this is different than the last problem. The last problem had a square root in the numerator and no square root in the denominator. These are not like terms, so you cannot do math with a radicand and a free number. But for this problem, we actually have a radicand on top, and we have a radical on the bottom. So technically we can write it as one giant radical sign with this fraction underneath. So this time I actually am allowed to divide 1215 by 5. And that's because they are both radical numbers. So I'm going to try that on my calculator. I'm going to divide 1215 by 5, and let's see what I get. I get 243. So let's just check the square root of 243. Okay, it's irrational. So I'm going to write here, let me see, I'm going to write it here. The square root of 243. And I'm just going to check to see if any of these values are a factor of 243, just to see if I can simplify it. So 243 divided by 81. Oh, that was a really lucky first guess. So 243 can be written as the square root of 81 times the square root of 3. Square root of 81 is 9. Square root of 3 cannot be found. So 9 square roots of 3 is my answer. 9 square roots of 3. All right, one more time here. Okay, the numerator and the denominator are not the same type of terms, so we cannot divide by 3. But we can simplify our numerator, 252. So here we go, square root of 252 over 3. So now I'm going to try and break up the square root of 252. Let's see what I can guess this time. Okay, I'll start with 81. Nope. Oh, I feel like I did this number already. I want to scroll up my calculator. Pretty sure I did this number already. 252 is divided by 16? No. 252 divided by 9? Ooh. But I don't think that's the biggest one. I jumped down too low. 252, 9 times 4, 36. 252 divided by, 252 divided by 36. There we go. 36 and 7. So that can be written as 6 square roots of 7 divided by 3. And these guys are like terms. They're both free coefficients. So these can actually be divided. And then we write the square root of 7 on the side. So 6 divided by 3 is 2. 2 square roots of 7 is our final answer. 2 square roots of 7. All right, did 3 from that section. Let's go to the next one, adding and subtracting radical forms. You cannot add radicands that don't match. You have to have common radicands, just like you have to have common variables, right? Or common denominators. 8 square roots of 2 plus 8 square roots of 50. So let me write that down for you. 8 square roots of 2 plus 8 square roots of 50. They need to match. This one can be made smaller, but this one cannot be made bigger. So we need to have a square root of 2 over here, for sure. So let's find out what's missing. What times 2 makes 50? 25. So this 25 will come out, but the 2 will stay under. And 8 times 5 is 40. So this is actually 40 square roots of 2, and now we can add it to 8 square roots of 2. 8 and 40 combined, 48, and the square root of 2 remains the same. 48 square roots of 2. 48 square roots of 2. All right, we've got square root of 12 and square root of 3. This is the smaller radicand, so that must be what we want this 12 to turn into. So negative 9 square roots of 12 plus 5 square roots of 3. So I know I want a square root of 3 over here. Question is, what times 3 makes 12? And that's 4. So the 4 will come out because it's a perfect square. It comes out as a 2. And when you come out, you multiply anybody else that was out there. So negative 18 square roots of 3 plus 5 square roots of 3 equals negative 13 square roots of 3. Pause the video if you need to look that over a bit more. 13 square roots of 3. Negative 13 square roots of 3. Okay. One more? You feel like you need one more? All right, square root of 3 and 192. Square root of 3 plus the square root of 192. I know I need a square root of 3 over here. So I'm gonna divide, because I don't know, 192 divided by 3. And please be a perfect square. Yes! That's 8 square roots of 3 plus, how many square roots of 3 over here? 1. 9 square roots of 3. 9 square roots of 3. All right, I'm going to move on to the next topic here, which is rationalizing denominators. Now, this is a new one. This is kind of tough, but you cannot have a radical in the denominator when you are finished doing any sort of math. So if your answer was 2 square roots of 3, 2 over the square root of 3, you would have to do something called rationalize the denominator. And it's quite a simple process. All you have to do really here is multiply it by itself. Because when you do that, the square root of 3 times the square root of 3 is also known as the square root of 3 squared, right? And squares and square roots cancel each other out. So that's why we choose to multiply the denominator by itself. But you can't do it to just the denominator. You also have to do it to the numerator. So we choose to multiply by itself because we know it will result in the radicand being set free, right? Square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. Up here, that's what you get. These two cannot divide because they are not alike. One is a free coefficient and one is a radicand. So your final answer is 2 square roots of 3 over 3. So we're going to write 2 square roots 3, division bar, whoops. I'll write the division bar first. 2 square roots of 3, then arrow down. Let's try this one more time. Let's rationalize this denominator. 4 over the square root of 63. 4 over the square root of 63. We're going to multiply this by the square root of 63. We're going to multiply this by the square root of 63. This will become just a 63. And this will become the product. 4 square roots of 63 over 63. Can 63 be simplified? That's the question. I know 3 goes into 63. 21 times. And 3 also goes into 21. Oh, 63 is 9 times 7, right? Let's check that. 63 divided by 9. Oh, yeah. So this is actually 4 times 9, square root of 9 times square root of 7. And this is a 3. So 4 times 3 is 12, square root of 7 over 63. I think this can be reduced. 12 over 63. I don't know it, so I'm just going to pick up my calculator and let it do the math. I'm pretty sure it has some sort of 3 factor. So we get 4/21. All right, so, wow, that was a lot of math. This is going to reduce to 4 over 21, but the square root of 7 will remain. Wow, that. You might need to pause the video and really take a look at this for a second. 4 square roots of 7 over 21. Fraction. 4 square root of 7 over 21. Okay, one more time. 3 over the square root of 28. 3 square roots of 28. I'm going to multiply them both by the square root of 28. That leaves me with 3 square roots of 28 over 28. And I know that 28 can be written as 4 times 7. Or, let me erase this part here and extend this part here. So the square root of 4 comes out as a 2. And 3 times 2 is 6. And now what I need to check is, can 6/28 be reduced? I know definitely in half. So half of 6, half of 28. I didn't need to use my calculator, but you certainly could have. You could have typed in your calculator the fraction of, whoops, what did I do? Alpha y equals, what was it, 6 over 28? You can do that. 3/14. Did I get that right? Yeah. 3 square roots of 7 over 14. Pause the video if you need a bit more time with this. 3 square root 7 over 14. All right. Last 2 topics. This is for our next unit on polynomials. Standard form means that your highest exponent is first. And then all of the exponents after it go in descending order. So I really want to highlight what our terms are here. So our terms are 5x to the 4th, positive 1/6, positive 4x, and negative x cubed. So the highest for us was 4x to the 4th. That's the highest power. So 5x to the 4th is our first term. After that needs to be the power less than 4 in descending order, which would be 3. Notice that has a negative value, negative x to the 3rd. All right, now my next one would be x squared, but I don't see any x squareds. So I'm going to go to my x to the 1 power, which is positive 4x. And then I'm going to go to my x to the 0 power, which means there's no x's, right? So this is my final standard form expression. 5x to the 4th minus 3x cubed plus 4x plus 1/6. And type here 5x. You get a power. You can get a power by pressing Shift 6. Shift 6. So when you're here, Shift 6 puts you up in the power position. Then I have minus x shift 6, and then I have plus 4x, and then I have plus 1 fraction bar 6. Whoops, I put an equal sign by accident. Alright, I'm going to do this one more time, but I think this is pretty basic. I gotta fix my plus signs. I accidentally put equal signs. Alright, one more time. My highest power is x to the 4th. Happens to be negative x to the 4th. My next one is x to the 3 plus 5x to the 3. My next one is x squared, which happens to be a fraction. So it's x squared. Don't forget the exponent is shift 6. And then after that is a plus 1. Remember, these signs go with their values, right? The sign goes with the value. All right, I'm going to do the last one here. Adding and subtracting polynomials is a fancy word for combining like terms. So I'm going to add here negative 10x squared plus 4. I like to line mine up vertically, so I'm going to add negative 9x, which is not alike with x squared, and then minus 6. Notice I kind of shoved him here in the middle, because your answer should be in descending order, or standard form. So negative 10x squared plus minus 9x, because it's a minus 9x, I'm sorry, not 6, minus 2. Did I write 4 and minus 6 is negative 2. I don't know what I was saying. 4 and minus 6 is negative 2. All right, next one. Find the sum. Sum is adding. So what have I got here? I've got a negative 7x squared. Okay. Negative 7x squared minus 1. And in here I have adding x squared minus x and minus 5. So these can go together. This cannot go with anything. And these can go together. There we go. Negative 6x squared minus x minus 6. Minus x minus 6. You can also use this keyboard over here to get exponents. Did I do that right? Yes. All right, that concludes homework number 24.